And then you did that 8 different times. So that's the total length of your sampling plane. Thank you, Maria. Make sense? So you would put that there. So what was the length of your 0 to your quarter to 1? And you can look, remember it's at the top of the sheet. Quarter to 1.
Oh, so I made a mistake.
I don't think you did.
It's 6 feet.
6 feet for quarter to 1 as well, right? So what's the total length of your sampling line?
48.
What's that?
48.
Because you're good at math. That's good. 48 is the total length of your sampling line. What is it for the 1 to 3? 12 times 8?
400.
Did I hear a 400?
Yeah.
That's 12 times 8?
No.
Oh, 12 times 8?
96.
Yeah.
I was thinking about the,
Yeah, so your total length of sampling line would be 48, 48, 96. You got to make sure you get this right, because otherwise it's like the same as having too many plots. Because remember, your length, each one of your segments is one plot, so you want to add those up correctly. So what is it for the 3-inch plus? What's the total length of the sampling line for the 3-inch plus? What is it? 50 feet, right? Was our length of our sampling line times 8, 400 feet.
And
Ask as many questions.
okay, so, and I'm starting to get confused. So if you take 16 sampling lines, it's times 16.
It's times 16.
Okay, just making sure.
No, you gotta. That's a good question. That's why you gotta know how many plots you have. Exactly. And that's why you have to input this. Is why it's not a fixed. Right? You have to input it every time. So if you do 10 plots, 8 plots, 16 plots, however many, you have to multiply it by. That is why on the top of the sheet you have the length of the sampling plane, because later you're going to need to go back and do that multiplication. Because you need to know what the length of your sampling plane was. Okay, so that's your first step, is to set up that in the spreadsheet. And we'll go back and we'll actually do this in Excel. Okay, just going through it now. Everyone copy that? Make sure you do that right. Very important. Because otherwise you're either over or under predicting.
I think the suppression battalion thing is looking a lot different now.
You want to do that? This is easy. That's why you have fuel
I'm just
stacks.
messing with you.
That's why you have 80 miners. Alright. Okay, so again, n lambda, length of the sampling line, get it from here, 6, 12, and 50. And it screws me up because this really should, this 0 to 1 covers the first 2. So I always trip up on that, so I always have to remember. But the way it's just the way it's broken up. So first 2, third, and then the 4th one right there. Okay, this is the actual, this is an example data sheet from the actual Brown's books. This is a slide from the actual Brown book if you look in there. This is what the actual algorithm looks like. So basically what this Excel spreadsheet is doing for you is doing, for the 0 to 3 inch, it's doing this algorithm, and then it's doing this algorithm for the 3 inch. So you don't have to, for your convenience. Although, all these things we're going to talk about, like the N, the D2, the SA, all this stuff, the sigma, you could figure these out and then you just multiply. You could just do it, right? You know, it's not complicated. But again, the Excel spreadsheet does it for you. Okay, and this is what I filled out. This is the computational summary. So this is like, if you were going to do it by hand, you would have the N, the D2, all these numbers, you would go and figure out what these variables are. We'll come back to this, because this will make more sense in a bit after we actually go through it. So again, this is, if you were going to do it by hand, 0 to 3, this is for the top part, and then the 3 plus is down here on the second part on the bottom. It's actually not too hard to do. So N, which is the number of intercepts by the size class. This is the 3 size class, the 110 and the hundreds. Again, what you're doing is you're adding the total number of times that the sampling plane was intercepted, so the total number of intercepts. It's just N just is the Latin for number, if you do statistics and math. And again, there's a worksheet to assist this. So there's an actual worksheet, which is this one. This is the worksheet in the product. And all you do is you have your plots on the left, and it's auto-filled for up to 20 plots. We did 8 in ours, but on this example there's 10. And so, you know, this corresponds to your columns on your sheet. So if you look at your sheet, plot 1, that's the number of intercepts. For 0 to quarter, quarter to 1, quarter to 3, those are your intercepts across. And you just make sure that you input it correctly. So there's always going to be 3 per plot, right? From your data sheet. If you look at the data sheet, there's always going to be 3 per plot. And all you do is really, it's really pretty quick. You just plot 1, plot 2, plot 3, plot 4, for those in. And this is just the number of times that the plane was intercepted. Okay, and then what it does is it goes and it autofills this, because remember it's the black boxes. It goes from this sheet, that 165, 35, and 7, and it autofills out to here. So you don't have to go and type it in yourself. Okay, and so the next thing is the d squared average quadratic mean diameter. I don't know what this stuff means, and it's in your Brown's book. So again, this is the first one where it's a preset input, and there's a range of options. So you have to make some decisions. You have to actually look at. You actually need to have your Brown's book in order to do this Excel sheet. You have to have the Brown's book to be able to look at the variables, and so. Hopefully you can grab those books and we'll see what page it's on. So again, you have to set it when you're doing the calculations, and it's divided into 2 main categories. You have your slash or your non-slash. Hopefully you guys all know who Mr. Saul Hudson is out here. Mr. DeLong?
Yes.
Yes, thank you. Do we know that Mr. Saul Hudson and band is going to be playing in Qualcomm Stadium in August?
Yes.
You guys hear? Yeah. Gunners fans? Jose? All right.
He's somewhere else.
No, I have no idea.
Gunners? Guns N' Roses?
Okay, yeah,
Oh my God.
sorry.
All right. So you must choose slash or non-slash, but only one, and there can only be one true slash. There's only one slash. You ever see the South Park with slash? Slash is not real. Okay, so again, this is from page 16 in the Brown's book. If you want to break it out, this is the table. So you have to, again, if you want to do this Excel spreadsheet, you have to have the Brown's book, and you have to be able to go look at these tables. This whole PowerPoint will teach you how to do all of this if you just follow it. I'll be real curious. Is this in line with what you guys were doing?
Yeah, but we haven't gotten to this part yet.
Okay. All right. Cool.
Yep.
Yeah, I've been thinking about this whole time, so I know you guys were wanting it.
I'm kind of holding on to it. People have been asking for it, and I'm like,
Okay. So let's just use the example we did at Laguna, right? So we have non-slash and slash. Were we in non-slash or slash? Were we in activity? Were we in natural fuels or activity fuels?
Activity.
You think we're in activity fuels? Ignore the chips because we weren't counting the chips.
Not slash.
I would say non-slash. Alright, so it doesn't give you a ton of options here. And again, we have to always look at this size class inches because there's some division here. You have cover type 1, so anyway, blah, 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 PP, LP, SDF, AF, those all refer to trees, and then composite just means the composite values are averages of non-slash and slash fields with each cover type. Anyway, what this means is you need to choose whether if you were in something that looks like ponderosa pine, then you would use 0.0342. If you were in something that looked like lodgepole pine, or were in lodgepole pine, you would use 0.0201 for D squared. Remember, for the block for D squared? Again, this all come together at the end, don't worry. If you were in something that looked like Engelmann spruce, Douglas fir, is that Aves? Alpine, yeah, subalpine fir. Yeah, so high elevation stuff. Or C, which is western red cedar, you would use 0.0122. L is, what's L? Larch, western larch. If you were in something that looked like western larch, you would use that. Or if you were in none of these and none of this, you would just use this composite, which is more or less an average of all those. Okay? And then, so again, these are your ranges of choices, and these ranges of choices are what's built into the Excel spreadsheet where you can drop down. So what do you think, what would you use for what we were in Mount Laguna? What do you think? Any thoughts?
Composite.
You think composite? Your other thoughts? 0.0122? Nah, I don't think we're anything that looked like grand fir or any of that. I personally would use the PP, which is ponderosa pine, because ponderosa pine is basically the same as Jeffrey pine. And Mount Laguna is primarily long-needled Jeffrey pine. It's very closely related. So me personally, and again, whatever, you can use composite and it's not really going to be a big difference. But I would use the ponderosa pine, personally, for Laguna, just because it's very silviculturally similar. Any objections from that? And then you just do the same thing for the 0 to quarter, quarter to 1, 1 to 3. You have to look at these numbers and then choose which one you want to use. And again, and we're choosing non-slash, but if you use slash, you have to go over here. Same thing, you have more or less the same choices. Tends to be some fewer choices in slash, but you want to make sure you're using the right pull downs. So the way this looks is when you come back to the Excel spreadsheet, you have the D squared. And this is for the less than 3 inch size classes. So I don't know if this necessarily correlates to our example, but this is the pull down. You guys want me to show you on the Excel spreadsheet what that looks like? Real quick?
Yeah. Please.
Okay. So what that looks like on the Excel spreadsheet is this, where you come to the squared average quadratic mean diameter and you just click on these little boxes. See how it brings up the little radio button next to it? That's what these are called. And so those numbers are pre-fed in here. So I think 0.0342 is the top one. And you really would use the, okay, so they're different numbers in different boxes. Let's see. Now I don't have the,
This is why you need the book.
what's that?
This is why you need the book.
Yeah, this is why you need exactly, the book instead of this. So why would want to use 0.0342 and then 0.344 and then 3.12, which are, or actually no, you got to be careful. You got to be super careful.
Yeah, because it changed around.
Because they changed it, yeah, because Ponderosa Pine is actually down here at the 0.238. See that? So you got to check that, and then Ponderosa Pine is back up at the top here. So it's the top, 0.238, yeah. Everybody follow that? So help me out here. What are we doing? 0.342, 0.238, right?
Yep.
And then the 3.12?
Yeah.
Okay. Actually, since we're doing this, we might as well start putting in some numbers, right? You guys want to do that? You want to do the 0 to 3 inch tally sheet?
Yeah.
All right, somebody who's got a data sheet, and we'll just pick one data sheet and we'll go through it. I'll show you what this looks like.
I got one.
All right, Reyes has one. So, again, this is the 0 to 3 inch tally sheet. This is just the number of intercepts. So we have 8 plots, so you should give me 3 numbers per plot. So you want to hit me? What?
I got 3, 1, and 0.
3, 1, and 0. And I also always recommend that if there's a 0, you actually put in the 0, because otherwise you'll start to lose track of where you're at with your plots and everything. Even though 0 won't add anything, it just helps you keep track that you didn't forget it. All right, so plot 2.
0, 3, 2.
Okay.
0, 1, 4.
Okay.
0, 1, 2.
0, 1, 2.
0, 2, 2.
0, 2, 2. Okay.
0, 1, 0.
0, 1, 0.
0, 2, 1.
Okay.
And 0, 0, 0.
All right, cool. So see how simple that is? Then you go back to the planar calculation sheet and see how it's added. It's just put into there. The reason is because the calculations are, there's actually, I think there's another sheet. Let me see if I can find it. It says keep but ignore. This has all the settings and I think some of the actual calculations are back there too. So, okay, so we've done the intercepts by size class. We've done the squared average quadratic mean diameter. See the specific gravity one? I can't click on this. And if you actually go to the S, well, I think I'm getting ahead of myself, but if you go to the S page, it'll show you. All right. So that's how you do that. So you have to know those little radio buttons to pull those down to do this correctly, because otherwise whatever is in the sheet when you get there is either going to be correct, but it's probably going to be wrong. So that's D squared. That's how you enter that. Again, the specific gravity one is, this number is fixed in the equation, so don't stress about it, don't worry about it. Just move on past that one. But on page 17, it does actually show you the numbers to make sure that they're correct in there. So that's the specific gravity in the material. And then again, it shows up here and it shows up there. It's in the white box. The white box means you can't change it. Okay, now we have the non-horizontal angle correction factor, which is A. Again, this one is divided into slash and non-slash. And so for slash, it's either Ponderosa Pine or other, so that's pretty simple. And then and it's also divided into fresh slash, which is 1 year old, or 1 year and older slash. Yeah, you like that? The old slash video is hilarious. This is what happens to old slash. Yeah, for kids and trophy wives. It's not wearing shoes. Alright, just a little joke. Alright, so anyway, so again for A, at the top, yeah, this is non-slash, there's only two, if it's non-slash, then there's really not much option, that's what it is. It's either it's 1.13 for 0.3 and it's 1.03. But if it is slash, you have to decide, okay, by size class, is it fresh or is it 1 year or older slash? Okay, so activity fuel. So for our example at Mount Laguna, what would we use? Now, because remember slash is activity fuels that's been cut, that's lying around. So we were just doing a regular old natural fuels up there, besides the chips, but we weren't counting the chips because we weren't measuring them. So we would actually ignore all this, which is totally hard. We would go to this non-slash and just use 1.13 and 1.0. Okay? So let's go back to the sheet, see where we're at. Which one is this, A?
Yes.
So what is it, 1.13? That one's already 1.13. And then for the big stuff, oh, that's right, for both of them, see how this is fixed at A, is 1? So for both of them, it's actually fixed. Yeah, if you look down here at the 3 plus, it's also 1.1, the same as 1.0 for slash and non-slash. So that's why in the sheet it's shown as a fixed one because it's the same number. Is there everyone following so far? All right, you good? You good? You good? All right. Okay, so that's A. Again, this is just going through an old example. This is where it shows up, right here in A. Okay, so the next one is C, slope correction factor. Now this is where, remember how I said you gotta make sure you take the slope in your data sheet and it's one of the columns? This is why. So what you do is you average the slope for the whole unit, so you take all your slopes. So we're gonna need you guys, since we're using your data sheet, to get your slopes and average them. And then, yeah, good. I think this is actually the one I used when I did up my stuff too. So what's your average slope? So you add them all up and then you divide by the number of plots, right? Where do you guys got?
7.
7. Okay. So you add it all up and divide it by 8.
19.
Do you got the sheet, Sue?
This one?
Oh, are you looking at? No, the Excel.
No,
Oh, okay, damn.
I'm trying to find it.
You got 15.
Double checking.
Yeah, double check
You
that.
need to check his accuracy?
Yeah.
Does that wrong?
Well, I got a different number.
No, I think he just said one.
That's your math app?
Can we get that?
15.
Really?
You're really
Is
thinking
it
of
13, 14, 18, 19?
That's what I mean.
Can't find it.
No, that's not right.
Wait, say it again? Say it again?
13, 14,
Divided by 8.
14.
8, 6.
No, see right there, that's where I just like sabotage
Alright, what is it?
I got it. We divided it by 6. So it's 11.25.
11.25?
Here, let me put my calculator too.
You can bring my iPad.
Everybody.
So the buttons are gonna take.
Just one.
Alright, what do we got? 11?
11.25.
11.25. Alright, so they exist in 10% increments, so it's a pretty rough calculation. And of course, make sure you use percent, and the worksheet, of course, also has drop downs. So it goes 0, 10, 10, 20, 10, blah, blah, 10%. So what is it, 11 or something? So I always default down to the bottom or whatever's closest. So in this case, I would use the one that's at 10%, which is 1.0, which is actually the same as 0. So again, these are all a whole range of numbers, so all the way up to 110%. So that's a range of numbers. So again, C is something we have to go in and input. So let's show what that looks like. So for C, what was it again, 1.0? So scroll up. So all these numbers, and see how it's changing the numerator here? It's changing it because it's changing that calculation. That number right there. Oh, we forgot to put the total length of the sampling line. What was it, 48? Is it 48?
Yes.
4896.
4896 and 400.
Okay, see how it's changing stuff too? Alright, cool. And alright. So that's the slope correction factor. Next one. Oh, that's just showing what the slope is. Yeah, the slope on here was 23. That's right. That's why I had a different number because I was doing the math on this one. My apologies. I was like, it should be 23 when I look at your numbers. You don't have anything higher than, so forget. I'm an idiot. All right. So that would be the slope correction for 23. That would be the slope correction factor. It'd be 1.02. So it'd be a little different. Okay, now we're getting to the sigma delta squared sum diameter. This is moving on to the 3-inch plus stuff. Okay, so the sound and rotten. Again, as we know, we collect the diameters of all those materials. That's 3-inch plus. We calculate the diameter squared separately for both the sound and rotten, so that's why they're in different categories. We square them, we sum them. Sum just means add. Again, this is all explained on page 17 to 18. And of course, we have a data calculation sheet for this one. This one's pretty easy. There's the sound, so the left is the sound, and then the right is the rotten. And all you gotta do is, it's not, again, this isn't by plot, of course, this is by the piece. So the first piece on your was 26, 9, 17, and then it does the automatically, it squares it. And over here is the rotten, so you put the rotten ones. So on your data sheets, you should have sound, right, and diameters, and you should have rotten diameters. And so we'll enter that we'll enter this in onto the Excel sheet. So what do you, okay, so and then there's the 3-inch tally sheet is what this one's called. So we'll start with sound. And this one kind of screws me up sometimes when I do it, so you have to be careful with it. So what do you got for diameters, Reyes? On all your sound pieces that are greater than 3-inch, what do you have? In no particular order.
3.5,
3.5,
5.0,
5.0,
7.0,
7, okay?
and then 4.0.
4.0.
Oh, I'm sorry. Shit, I messed you up, dude. Sorry.
Just 5 and 7, right? Just the sound, right? For
Just the sound.
Okay, it'll just be 5.
0.0 and 7.0.
So another 5 and another 7?
It's just
Total, sorry. I actually put the rotten in with that.
All
well,
right.
it's just two numbers, just 5.0 and 7.0.
Oh, really?
Yeah.
With sound.
For sound.
Yes.
And
So
then,
only 2
Yeah.
across all 3 of those columns?
For sound, yes.
Okay. What about for rotten?
3.5 and 4.0. Sorry.
That's all right. 3.5 and 4.0, that's it?
Mm-hmm.
So you only had 4 pieces on your entire data sheet that were 3-inch plus. All right. So you'll see that those come down here. And as soon as you plug this in, you actually get an output here for your tons per acre. And it gets calculated as less than 3-inch and greater than 3-inch, by the way. And then your total tons an acre. So that's that. Pretty straightforward, huh? Yeah. So I think there's a couple of little things on here. Oh, the Duff and the fuel bed depth. Okay, so that's the data calculation. You put all your sound pieces on this one side, put all your rotten pieces on the other. Autofills does all the math. Pretty slick. And of course, like I said, autofills there. So then there's 2 other data sheets, the Duff Depth and the fuel bed depth. Of course, 2 different worksheets. And you have to input in the main page the number of observations, so we'll show you that as well. So the one on the left is the Duff Depth. The one on the right is fuel bed. Again, on the left, it's by plot. So we would have 8 plots, and then remember with Duff, there's 2 readings. So you have your first reading and your second reading by plot. You just go across, and then the same thing with fuel bed depth. By plot, first one, second one, third one. This is where it's kind of nice that there's 2 and 3, because in your mind you kind of separates a little bit, and then it'll calculate it. So let's let's do that. Let's finish it up. So let's do, so the Duff depth sheet is the first one. So you do it by plot, so give me the first and second. Plot 1.
For depth though.
Yeah, Duff depth, yeah.
First one, we got 0.1.
0.1, okay. And the second on the same plot?
1.5,
1.5, okay.
and then
Plot 2,
Oh, that's a depth. That's right here.
Duff depth.
I'm sorry.
It's okay, it's part of it, learning.
So the first number would be 0.8. The second number would be
Wait, for plot 2 or for plot 1?
for plot 1. I gave
Okay. 0. What is it? 1.8?
Yeah.
0.18?
No, just 8. Or 0.8.
0.8, cap.
And
Alright.
then 1.
1.0, okay.
Mhm. Then for plot number 2, 2.0,
2, okay.
1.8.
Okay.
Plot number 3, 1.3, 1.5,
Okay.
1.0, 2.0,
Okay.
0.5, 1.5,
Okay.
2.0, 1.5,
0.5?
yes.
Okay.
And 1.0, 1.0,
Okay.
3.0, 1.0.
Alright, cool.
And also on the sound, I messed up and didn't give you a column, so it's more than
I thought you were missing something.
4. Sorry.
It's alright. So what is it? Sound?
We got 6, 9,
This is in addition to 5 and 7?
yes,
Okay, 5, 7, 6, 9.
4.5,
How much?
4,
4.5.
yeah, 3.5, 4.5, and then 5.
Sorry. That was my fault.
Yeah, I did your sheet the other day. That's why I was like, I thought there was more. So those are all sound. And there's 2 rotten, right?
And there's 2 rotten, yes.
Alright, yeah, so that's the thing, you have to look all the way across. I'm glad you caught that. Cool. Alright, so that was the Duff, so we come back to the front. So it autofills the Duff depths, and then you have to do the number of observations. So how many observations were there?
Yeah, 16.
16, that's right. So there's 2 times 8 plots. So that will give you an average Duff depth. Pretty cool, huh? Alright, and then we have fuel bed depth.
Sorry.
So again, 3 observations per plot. You guys prepared?
Yes.
Alright, what do you got for the first one?
So 0.1,
0.1,
1.5,
1.5.
and 0.1,
Plot 2.
0.1, 0, 1.0,
Okay.
0.1, 1.0, 0.8,
Okay.
0.5, 1.5, 0.1, 0.3, 0.5, 1.0, 0.2, 0.5, 1.5, 0.5, 1.0, 1.0, and then 0, 1.0, and 0.5.
Okay. And then how many observations were on this one?
Should be 24, right?
24, because it's 3 times 8 plots. Gives you the average fuel bed depth. So there's only one thing left. Basal area. So those are those sheets. And that's where it auto-populates down here. You have to manually input the number of observations, but that's no big thing. And then the last one, this is the variable. We did variable radius plot sampling, and this one's pretty easy. There's actually a sheet for it. This is how you calculate it. You just add the number of, there's 2 different ways. You just add the number of observations times 10 square feet was the basal area factor, and then you would divide it by the number of plots, or you could do this, add all of them together, as a multiple, or what do you call that, as a factor? Divided by 5 multiplies by 10, but whatever you want to do. Or you can just enter it into the sheet. But that's just a little math, which I'm not very good at, so I'm not going to pretend I am, but okay. So, and then the last one is this basal area calculation sheet. There's actually, this one on the left is for doing, when you actually, for a fixed radius plot, when you actually measure the trees, it'll calculate the basal area, it'll do that calculation. This one over on the right is the variable radius plot, so all you do is the number of trees tallied. So, you flip it over and just tell me the number of trees tallied. 8 times, I think, or 4 if you did the plot centers. Yeah.
Well, I got 110.
Oh, you did the math already. So if it's a,
That's what it says.
that's what it is. I don't think you've measured 110 trees.
Yeah.
So you multiplied it by 10 already. So if you divide it by 10, that'd be 11, right?
Yeah.
Okay.
Okay, yeah. So 11,
Uh-huh.
7, 9, 10,
Uh-huh.
11, 7, 9, and 10.
Okay. Cool. So yeah, the only way to get it to work on the sheet is this. So it auto populates down here, and this black one here, it just goes directly to date, which is the average basal area, which is the average basal area is 123.3. And that's where the 10 basal area factor prism. Of course, you need to make sure that you need to make sure that you're using. If you want to change the basal area factor, if you want to use a 5 or a 20, or obviously you need to change that here because it multiples. I think I set this up. If you change the first one, it changes the rest. Yeah. Oh, look how that. How about that? Huh? That's total bonus points. The only reason I knew that is because those are black, because that's my little signal for it. So and that's a finished basal. That's a finished brown sheet. It's actually pretty simple, especially if you have a partner to help you enter in the numbers. And that's all you gotta do. It's all automated for you. Copyright 2013. So, and then you just print that off, and then you have your tons per acre. So the tons per acre out there was less than 2 inches. It was 2.44, and it actually gives you a calculation up here if you want to know it. So the 1 hour was 0.01 tons per acre. 0.34 for the 10 hour, 1.88 for the 100 hour, 3.19 for the sound, and then not much rotten. So it's kind of interesting. You start characterizing the fuel bed out there. So if you were to get, a bunch of different units across the landscape, you could start comparing these. And then what the whole goal of this was to begin with was to do pre-burn, right? So I wanted to go out and to do a unit before a burn, and then to go out and do a burn after to see what that difference is. And this is really, I don't know if we talk about that at all, but yeah, whatever. In terms of actually trying to determine whether we met our objectives, especially our consumption objectives, this is the sort of thing that you have to do. This is why I want Brown's transects to be required for timber understory burning to have a consumption objective. Because how else are you going to know whether you consumed 80% of the 1 hour fuels and 90% of the 10 hour fuels, or whatever your objectives are? This is really the only way to do it. So we finally started doing it a little bit, where the fuels techs have started to go out and measure that. But again, this is the process. Instead of just being like, yeah, I think it looks good. Right?
I like that one.
Yeah, that way it's pretty visual.
Visual.
Yeah, the ocular estimation. As long as you call it ocular estimation, then you're fine. All right, so that's it. This one, we'll take a break. The exercise was to process your data. So what I would like for you guys to do is, if you want to get your data sheets or whatever you want to do, and you want to practice doing this, let me know. And like later, I can help you. If you just want to give me a phone call and be like, hey, I'm going through it. Because I think I've done all 3 of the data sheets, and I just need to. So we can make some copies. So I want those sheets back so I can make a copy, and then we'll make copies all. Is everyone clear on how to use that sheet?
That's for some.
That better?
Yeah. I don't know why I was dreading it, but yeah.
That's not too bad. All right, cool. Yes,
You
sir.
said you put this up on our page?
It's on the community page, yeah. I mean, I can always email it to you, but it's on the community page. You can download it. As well as this presentation, as well as the Browns book. So it's all on the community page. All right, let's take a break, 10 minutes, whatever. And we'll talk about it. 15. 10. You get 2 cigarettes out of it. What?